but it certainly means it's something you'd want to investigate a little bit further and determine whether or not that is fraud or not. But if I say anomaly detection, some people understand what I'm saying, but fraud detection, most people kind of get it. So we're looking for anomaly and fraud detection. And if you're looking for that, and you have lots and lots of data. Typically, you're looking for needles in haystacks, so that you're going to have even more data. You're going to be looking for tiny little needles that are sort of unusual little things that stand out. So what better place to do that than to bring the anomaly detection algorithms to the place where all the data is stored? And for a lot of people, that will be an Oracle database. If you have any follow-up questions or anything, you can always reach me at charlie.berger@Oracle. You can follow me on Twitter at charliedataMine. I'm writing a blog series called The Changing Role of the DBA, from Oracle Data Scientist from Oracle Data Professional to Oracle Data Scientist. You're welcome to follow that as well. I just posted that out there over the weekend, actually a new one. So with that, I'm Oracle. We always try to put out these safe harbor statements that says, basically, if I say anything about futures, and I will, don't take it, as gospel. It's a general direction. The goal of this presentation is to share information on Oracle machine learning that's embedded in the database, but also how to apply it, how to try and tackle this complex problem. And I don't mean to say that this is a simple problem. It's complex, it's hard, but how you might try to approach it using some of the algorithms that we have inside the database. And I'll show you how we can make parts of that a little bit easier. Now, when I first did this, I first got involved with a presentation specifically to the American Society of Fraud Examiners, I think is who they were called, and I got invited with a friend of mine, Dr. Carl Rexer from Rexer Analytics, and we went down to the Boston chapter and we presented on machine learning, how machine learning could be used for fraud. And it was interesting because Carl had done more work in fraud than I had at the time, and we decided, well, I decided I better learn a little bit more about fraud. So we started to poke around and do a little, like, what do these guys do? They have a whole society, and they write reports, and they have these studies and things. And it was interesting what they do. The other thing I was going to say was, most of the audience, at least at that time, and I'd say mostly probably still in large part, are people with more of an investigative kind of like a policeman, a cop, an investigator, a detective. People are really trying to track things down using their hunches and their intuition and all that. So it's an interesting society of people. And some of the things they found was that nearly 1 out of 10 Americans would, and this, apologize for the American local, 1 out of 10 Americans would commit insurance fraud if they knew they could get away with it. Nearly 1 in 4 say it's okay to defraud insurers. 2 out of 5 people are not very likely, or not likely at all, to report someone who has ripped off an insurer. Nearly 3 out of 10 Americans won't report insurance scams committed by someone else they know. And this goes on and on with how much it costs them and how prevalent this is. And I just didn't realize it was quite this prevalent and costly. They go on with this frauddiscovery.com and AuditNet links here that you can follow that say, well, this is how we do it today. There are 20 ways to detect fraud, and it's very easy. You have this unusual behavior. The perpetrator will often display unusual behavior that, taken as a whole, is a strong indicator of fraud. They might may not ever take a vacation or call in sick. They may not assign out of work even when overloaded. There may be complaints, either too many complaints or not enough complaints, stale items and reconciliations, excessive voids, missing documents, and so on. And this goes on and on. There are 20 of them, and when you read them all, they make perfect sense. You'd say, well, this is fairly easy to implement something like this, but is it? It really is just a bunch of business rules, and the rules change, and what you're trying to find is sort of elusive. Now, hopefully, or maybe not hopefully, but a lot of you may know the one rule that I think you'll learn when you get into fraud, which is there's a very famous rule, and it just happened to me the other day, actually. You go off and you take out a new credit card and you buy a small amount of gas with it, which is what I did, and then you go to a store and you make a relatively large purchase, and they'll question your transaction. You'll say, well, that sounds like a stolen card. You just tried it on a automated machine, and it worked, and now you're going to go for the big kill, the big score. And exactly what happened. And I questioned the clerk and said, well, that's kind of unusual. And then I just realized, well, it's not unusual. That's a well-known use case. And so some things can be kind of written down as rules, but fraudsters are clever people, and they do a lot of clever things. And so The idea is that maybe you could use some machine learning to help you solve these kind of problems. And so at this point, I'm going to talk a little bit about what machine learning is, then I'll talk about Oracle machine learning, and then I'll talk about how we can use Oracle machine learning to solve some problems. So machine learning, the definition is at the top is actually my definition. I've sort of amalgamated it from everything I've ever seen anybody else say, and that's the way I like to say it. What is machine learning? It's using algorithms to automatically sift through large amounts of data to discover hidden patterns. If you knew what the patterns were, you wouldn't need machine learning, right? Discover new insights, and ultimately, oftentimes, to make predictions. And depending on what you're doing, there are what we call supervised learning use cases and unsupervised learning use cases. The supervised learning use cases are usually when you have what we call labeled data. You have historical data that is labeled. This is fraudulent. This is not. This is tax fraud. This is not. This is a late invoice sort of a transaction that's suspicious. This one's not. These are medical claims that are identified as confirmed, fraudulent. These are ones that have not been. So if you have that kind of situation, and I know guys with check fraud and a bunch of kind of fraud where they say, yeah, I've got all sorts, sadly, they have all sorts of examples of fraud, then you can use the supervised learning techniques for that. And it's really just, like the classification, the one in the middle here. Find examples of fraud, find counter examples that are not fraud, build a classifier, and off you go. But in fraud, there's also usually not that many examples. You're still trying to discover, you're trying to find those needles. So when you lack a lot of examples, you might use something like anomaly detection, where you're training on the normal records and you're trying to flag those ones that are dissimilar to the training population. We have an algorithm called a one-class support vector machine that does exactly that. You might also use clustering. You might use, unsupervised, not necessarily for fraud. You might use association rules. So there's different categories of machine learning algorithms depending on what you are focusing on. For the purposes of this presentation, we're going to focus mostly on the anomaly detection, a little bit on clustering, and a little bit on the classification. So I also like to acknowledge where I borrow good stuff from, and I borrowed this from some people I used to work with way back a long time ago at Thinking Machines, Michael Barrier and Gordon Linoff, and I think they wrote, to this day, one of the best, books on machine learning. It's called Data Mining back in its day, but they had an example that was, very similar to this. They used dinosaurs rather than churners, but I basically just stole their idea. And if you try to take just two variables, income and customer months, and fit a straight line through this data, you can do it, but it's not such a good job. If I fit a little bit more of a curvature to that with some squared or cubic terms, it might pick up more of the blue guys down here, and it might separate this out a little bit better. But a machine learning algorithm would sort of carve through that like butter, and it would find every single cut point along there. It would sort of tessellate the data and find the curves in the data where the information gain is a little bit different, and it would just slice through this data and find those pockets. And a byproduct of that particular algorithm is that it also provides these nice, easy to read rules. If customer months is greater than 14 and income is less than 90, then I make a prediction that you're going to be a lease churner with a certain amount of confidence, because 8 out of 8 of them did do that, and the support is 8 out of 39 of them in that whole population. So we see it's about 25%. Similarly, up above, we have another segment, not quite as much confidence, a little bit smaller. But so what we're doing is we're providing insights and predictions. Now, the rules I want to point out, we also generate the rules using something called prediction details in the database. So regardless if it's an opaque algorithm like a neural network or a Gaussian support vector machine, we still have something called prediction details. Just look it up. It's prediction underscore details in the documentation, and it's a pretty useful, explanatory feature that we have. But what do you do in fraud? The idea is I have no or very few, very rare examples of what I'm looking for. So how do I fit a line through that, right? It's a lot harder. So what I do is kind of what I'm alluding to up here. I train up in the upper right-hand corner. I train on normal records, and so we're gonna try and see this in practice to kind of see what we're doing here and how this approach works. So hopefully some of you might remember the old cartoon guy Waldo, and Waldo would get stuck in a huge crowd like at the beach or at a store or someplace, and we'd be trying to find Waldo in a crowd. So I'm going to see how well your brain works for finding Waldo here. We're going to show a scene, and we're going to give you 10 seconds, and we're going to try and see if you can visually find Waldo. So get ready, set, go. Where's Waldo? Wow, there's a lot of people out there. Well, I'm going to accelerate this. Time's up. There he is. There's Waldo. Now, I don't know if you found him, but You might have been looking for his striped sweater. Striped sweater. There's another different guy where there's a striped jacket. You might be looking for his little. It's hard to see his little cap. You might be looking for, his glasses. Certain people that have glasses. So um, that's kind of what you do. You look for things that are different, things that stand out. And there are a lot of use cases where we're essentially trying to find Waldo with ATM fraud, credit card fraud, prescription fraud, you name it. There's a lot of use cases where you're really trying to find these things that are lurking and hidden out there that we're trying to stop. Now, one of my customer references is one, and I hate to say my favorite, but it really is a good one. It is the UK National Healthcare System, and there's a bunch of people that I helped a little bit when they got started. They're brilliant people. We've done them on TechCast. We had Phil Godfrey the other day doing something. You can look that up on the Analytics and Data Oracle user community website. And they started, I don't know, say 3 or 4 years ago maybe, and they've identified over $1 billion of potential fraud that they flagged using Oracle database with Oracle machine learning. Also, Oracle Analytics that plays a role in that as well. But they've sifted through this, and if you Google this, the punchline, the reason they're showing the dentist over here is that the punchline was they found a dentist that if what he had been submitting was correct, um, he would have had to have been drilling 85 cavities per hour. Now he claims that he just saved up all of his billings and turned them in at the end of the month, and that was just the way he did it. Which I don't, remember exactly how that whole thing turned out, but they certainly, found that and many other different things that kind of stood up as like, what's going on here? And they have, I think the numbers are now. I have a slide on it later on. 1.6 billion with a B, and I think it's over 400 or 500 million of confirmed fraud where they've actually investigated, sent it off the investigators, and said, "Yep, you're not entitled to that money. Give it back to us." And now they're in the process of reclaiming that money. But I think it's like $500 million of money that they've already identified they're getting back. So it's in the papers. It's a big public thing, and they use Oracle, and they use my stuff, Oracle Machine Learning, for that. Now, for those of you who have children or still watch Sesame Street yourself or whatever, there's this song that I think is really relevant when we're looking for fraud. And if you play the little YouTube video, Big Bird walks out and he sees four bowls of birdseed, and he's kind of musing to himself like, one of these things is not like the others. It's a little song. I'm not going to say it. One of these things doesn't belong. Can you tell me which thing? Can you tell which thing is not like the others by the time I finish my song? And then he kind of walks around and he basically points to the big bowl and says, "This one's different because it's bigger." That's what we're going to do with machine learning. So we're going to look at a bunch of data. Consider that a haystack of data. I mean, there's a bunch of different ways to do that. I'll cover other ones, but I'm going to first do the anomaly detection one. So here we have a bunch of data, and we have attribute x sub I, x sub 1, x sub 2, x sub 3. Those could be age, income, profession, or day of the week, and they're just a bunch of different variables. And you may have a record that is on the high or the low or the middle of any one of those attributes, and by itself it may or may not mean anything to you, but taken collectively, it may or may not look anomalous. Let's say you had a basketball player that was 7 feet tall. Okay, we see that a lot. The basketball player scored a lot of points. We see that too. He was also good on defense. Okay, that happens. And he also was a good dribbler. That's a little bit unusual. And he could run really, really fast. Well, as you go down every single variable, you say, well, you just don't hit it out of you don't peak it on every single variable. Sometimes you're good at some things, and you're not good at other things. So what you're really looking for is sifting through large amounts of data. Let the algorithms train on what you consider to be normal. And by the way, if you have anomalies in there, if you have this 7-footer that can dribble like anything, remove those records. Train on, try to find the anomalous records, train on the normal, and then apply that model of normalcy or normality to new records and flag them on the amount of dissimilarity they have to the rest of the training population. So it's really an automated way of sifting through large amounts of data to triage it and try to find a smaller amount of data that you can have humans or your investigators, your detectives, investigate them and see what's going on. It's unlikely with fraud, if you have very few examples, that you're really going to just build a model and say, that's it, right there, it's confirmed fraud. It's really going to be, we suspect that the shorter list of guys might be doing something weird here. Now, I wanted to kind of give you a little bit more reality of a real fraud. It hits home and it's very real. if you look at this, this was actually my own credit card. And if you look at it, you might say, well, there's the Monaco Cafe. He didn't go to Monaco, did he? Actually, I did go to Monaco, and I did it on my, I did it for a business trip for Oracle, but this is my personal credit card. So I bought I guess I had lunch there, a meal, I had a meal there with some wine and everything. I was with somebody else, and so there, that's a normal kind of charge. So that's nothing unusual, but you might flag that based on the word Monaco. You might flag it on the geospatial distance from where I am right now. You might flag it as an international charge. A few different things. If you keep on looking at this, you might start saying, gas station, boy, he buys a lot of gas. What's going on with all that? And if you totaled up the amount of purchases for gas compared to other people, or compared to my, monthly or weekly average, that might stand out as a lot of purchases at gas stations. You might have noticed that all these transactions are the same amount. Why, if I looked at a bunch of transactions and I counted up the count distinct of these transactions, I shouldn't have one, two, three, four different, 4 or 5 different numbers, and then one number appears in, repeating times. That would be a count distinct kind of calculation in the database that I could use. Um, Also, these things are in pairs of $75, 1 minute apart. So you might have the time between transactions might be another variable that you might want to track. And so, also, if you look at the window of time, the amount of purchases, if you use the SQL windowing function, you might say that Charlie was buying a certain amount of gas or food or whatever in each of these different categories as a 3 month moving average. But more recently, in the last 24 hours or so, it's jumped up. It's 3 times the longer range average. And all these are the kind of things that a clever Oracle data professional would do to serve up towards the data scientist that is eventually going to press go on an algorithm. But what I'm trying to communicate here is this is all the hard work and using your intuition to serve up the right variables that might be indicative of possible, anomalous or fraudulent behavior. And this goes into the statement that I always like from Albert Einstein that says, if I am asked to solve a problem, I'd spend the first 55 minutes thinking about the problem and then 5 minutes thinking about the solution. So we're going to try and do that here. It may not be like when we were doing the insurance fraud, the medical insurance fraud with the UK National Healthcare. I was brought into that, and I said, well, what are you trying to solve? Are you trying to find physicians that are doing bad things, patients that are doing bad things, or transactions like medical claims that are, procedures that are, medical claims for submission that are maybe suspicious, and then I can add and roll those up to the physician, to the patient, and that's what they were doing. That's what we eventually did, was we broke it up by the claims, and then you can roll those up by other people and chase after Dr. Smith or Jones or whatever, or patient Smith or Jones. So you really want to give a fair amount of time to that, kind of thought. Now, to put some of this in context, I just want to quickly go through some customer successes so you kind of see, examples, public examples. What I find with fraud is I know a lot of people that have either had fraud or used machine learning, and sometimes use my product for machine learning, but they don't always want to come out and say what they do with it because they consider it, first, sometimes a little bit embarrassing that they have fraud in the first place, but also they don't want to reveal to the fraudsters just exactly what they're doing. So here are a few people who have been kind enough to share what they're doing. This is the UK NHS one that I mentioned before. Over $1 billion in save. You can see what's there, and if you go to the oracle.com/machine learning website, you can go down and drill down and see the customer presentations and testimonials on this. Fiserv is a customer that I first kind of met up with a while ago, and they really impressed upon me some of the advantages of our in-database functionality, because they said that they build fraud models, but they build them in SAS. You might think of Python or anything else, but they were building them in SAS, and then they had to implement that and kind of vet it, make sure it was a good one, and then implement it to run inside the database in a fast way, and it was taking them 3 months to do that. With Oracle machine learning and the algorithms that are inside the database, they were able to bring that down to the same day. Turkcell, looking at sort of phone card fraud. They again were using SAS as an external kind of process, and they brought that all inside the database. StubHub is these are all public references. You can see define in their own words what they say and how they do it and so on. StubHub uses actually our integration with R to make callouts. So they do a lot of the data preparation and getting it all ready to go, and then they had written some equations in R language that they just do a call out to R and ask R to do that last little bit of the equation, and that's what they do. So there's just a teaser of a few different examples. Obviously, there's plenty of other ones. I'm working with a guy right now. I guess I shouldn't show that one. I'm working with a guy right now that has impressed me. He's doing check fraud, and he just knows his domain. He knows if I write a check here and I'm 3,000 miles away, and I write another check over there, and then I have X number of checks that I usually write, and so on. That he has a lot of clever derived variables. I know another guy that was doing check fraud at a local bank here, and he was doing the same sort of thing with these SQL windowing functions. So there's a lot of cleverness that goes into this. Anti-money laundering is another kind of use case where you really want to serve up the right variables to then feed the algorithms. It has less to do with the algorithms and more to do with the variables. So Oracle Machine Learning is the platform that we're going to use to try and tackle these problems. It is now a free feature of the database. So as of December 5th, 2019, Oracle Machine Learning became a no license required feature of the database. So if you have, anything from 11G R2 forward in the Enterprise Edition, the SE2 Edition, or any of the autonomous databases, all of what I'm going to show you is for free. So I lately feel like I'm Santa Claus telling everyone, free beer for everyone. There's a lot of cool things out there. And so what this does is it extends the database and enables users to build, quote, AI applications and use and leverage the powerful in-database algorithms and using the SQL or our integration with R and in the very short coming weeks, Python integration later on this fall. And so wow, I mean, because we're not in a live audience here, I'm going to say, wow, I'm doing that for you. This is pretty amazing, and it really opens up a lot of opportunities, I think. The algorithms that we're going to use we're going to focus a little bit more on the anomaly detection over here on the left, and a little bit on the clustering. We're going to focus a little bit on the classification as well when we have a lot of examples, but there's a whole range of algorithms that you can use, and the thing I always like to point out is that it's down in the fine print. If you want to do a model partitioned by region, partitioned by medical, type doctor, physician practice type. Is it orthodontist or orthopedics? And is it, of all the orthopedics, are they different ranges? One guy does knees, another guy does shoulders, and so on. So you may want to separate those out partitioned by, but you also may want to use like clustering to find natural subpopulations and then push those clusters through downstream anomaly, regression or anomaly detection models. So there's a lot of things you can do here. If some of your data is unstructured data, we support unstructured data using Oracle text to tokenize that data. If a lot of your data, and in fraud I think it is transactional, and you have, here's a purchase, here's some opioids, here's some more opioids, I can aggregate all those up, and I don't have to explode that out into another column in the database. I can use that as a nested table. So I can aggregate all the purchases of items A or B or C, or all the drugs of, like, say, opioid type, and I can compare that to how many opioids the population average usually is receiving, and just do a lot of cleverness. You can use geospatial data and say the distance, like in that check fraud example, or graph relationship kind of data, like how many interactions have I had for how much time or duration with people on, say, a suspects list. So there's a lot of clever things you can do here. We also have a number of statistical functions that people always forget about, but they've been in the database since 10G R2, and they're available for you to do a lot of clever things with. Now, I also wanted to show this because there's SQL for pattern matching. There are lead lag functions, there's aggregate functions, regular expression searches. So if you're looking like for a part number and you want to do a regular expression search, like is it a sequence of numbers, it is a certain range, there's a lot of little sort of like SQL pattern matching, like I call you, you call me, I call you back, all within the course of a minute, that may indicate a dropped call. So there are little atomic level SQL function, analytical functions that would go into your anomaly detection methodology. And you can do it all using the power and scalability and security and everything of the database without having to move the data somewhere else. When you build the models, it's as simple as this, right? Begin DBMS data mining, create model. There's a create model, there's a create model 2 that allows you to do things without the settings table and just sort of declare things. But I'm going to build a classification model. The target field is going to be customer insurance lifetime value. The target field is by insurance. So I'm doing classification where I've labeled data. I'll show the unsupervised in a minute. And then when I've built my model, I can apply the model as I'm doing here, maybe with some, information. You're at the border and I'm trying to let you through, and you're telling me, have you had your, do you have your papers? Do you have your test results? Do you have, whatever you're supposed to have? And I think it's one thing like your age is 22, and you go, no, I'm 62 or whatever. I can do a new score right on the fly because the model is right there as part of either the database, or I can export the model or use REST services. Very easy to deploy these. Here's an example of doing an attribute importance. So it's the same sort of syntax. We're just trying to find the key variables here, but just do an attribute importance. So I get the 0.2161. But if you say, no, Charlie, I don't speak SQL, I speak R. Well, as I said earlier on, we wrap and expose those same algorithms to R. We also wrap and expose those same algorithms to Python. So if you want to speak your native tongue, R or Python, and still run the algorithms on the data that's all inside the database, using those 30 algorithms I showed you, you'll still get the same results. So we try to expose our 30 algorithms, 30 plus algorithms, I think we're up to 32 or 33 now, out to data scientists and data professionals, regardless of the language they use. And because machine learning is such a data science is such a team sport these days, chances are you have multiple people on the team all speaking different languages. So in total, what we're looking at for an offering is Oracle Machine Learning that is gonna, so Oracle's trying to manage and analyze all your data. And as far as the machine learning stuff goes, we have the R Studio integration. For you speak R, it pushes down to the SQL. You have the drag and drop Oracle Data Miner, which I'll show a little bit of fraud use cases there, and you have the notebooks. You also have algorithms that run outside the database, Oracle Machine Learning for Spark. And I think the key here also is you may have a lot of data that's coming off wires, it's out in Hadoop or whatever, and you may want to boil down that data lake and bring in subtotals, counts, changes over time, what's the rate of change of the number of checks written or the amount of checks written and things like that. So you can assemble all this together. I always say that the centroid of all that assembled data is anywhere close to the Oracle database, just continue right on and do the rest of the computation and the math there, because the database has gotten very good at that lately. And as I said a few different times, probably it's all free. You might as well. You can also, in the area of sort of switching a little bit more out into the anomaly detection sort of nuances and stuff here, if you have data that has graph or spatial relationships, I might be able to use, I can use geospatial location data summarized to the percent time spent in certain areas, or the number of quote hits near a location. How many times have you been seen within 5 miles of the nuclear power plant? Something like that. Network relationships. If you have, and this would be stored as like transactional data. Here he is, here he is, here he is. But I can count up the number in total, the number of interactions with, say, people on my bad list. I can then join all that data together, including structured data, unstructured data, transactional data, graph data, and put it all together and do a real sort of 360-degree view of my customer. Now, once you've built that model, the key thing I always like to point out is how long does it take you to deploy that model? And if you look at this very, very fine study by Fern Halper, she talks about how it's 3 months to 5 months, 6 to 9 months. It's quite a bit of time, and I think that adds up to like 65% of the population is taking at least 3 months to maybe never. Now, for me, this is my editorial point of view on top of Fern's most excellent study. I say, well, they must be using products like that, because if they were using my stuff, it would be immediate. Okay, and I want to, I think right about now, see if I can vector over here to something just to give you a feel for that. So now I am going to show this in a drag and drop GUI kind of thing in a minute, but I'll show this so you can kind of see what's going on here. I'll come back to this. But right here, I have a little script here that is just a straightforward one. And this is the settings table. I could do it the other way. But if I run that little settings table, it's just instantiating, saying I'm going to do a support vector machine and auto data preparation is on. And I could just have that on the settings. Instead of the settings table 2, I could go claims model 2 and do it sort of directly there. Here's where I'm going to build the model. And I'm just going to build the model here. So I just built a model on 15,000 records, about 30 attributes, right on my laptop, just like that. And if I want to say, well, show me the top 5 most suspicious records, it's just a query, and there they are. And so I could just sort of put a button on this, put a scheduler on this, and run this thing over and over and over again, and just keep on running it, spit out any exceptions where the last name was Burger or whatever I want to do. I could do that pretty easily. I could also come over here and do the same sort of thing over here where I'm running a support vector machine and I have these algorithm settings, a linear, a Gaussian model, and I could do this from the GUI. And if I just did this, I could partition this. I could do sampling, the input variables. I could say that marital status here was actually text, and do a lot of things. I'm kind of skipping ahead here a little bit, but if I want to do this um, through the GUI, it's going to do the same sort of thing. So I have GUI, I have Notebook, which I'll show you in a minute. I have the APIs. The APIs are by far the fastest, most direct way to go, right? And that's all we're going to do is just build a model, score the model. I just did it, and here are my most suspicious claims. I can sort these guys based on the probability of them being, suspicious, anomalous. Here's a guy 70% likely to be anomalous. This is automobile insurance kind of claims. I'll show this in another way in a minute. But if I want to see the reasons why, this is called prediction details, and I'm showing the top, I don't know, dozen reasons because I'm trying to track these people down and say, well, what's going on? I can say, well, your deductible was 500. There were 2 vehicles in this. You changed your address in the last 2 or 3 years, and for whether that's the reason or not, it may be a smoking gun or not, but it at least gives the investigator some reason, some explanation for why the algorithm flagged them. So I wanted to show you that it can be that simple and easy. So now let's move into how we might approach fraud. So we're going to jump into the Oracle Machine Learning notebooks first. These are Zeppelin-based notebooks. They're meant to be a collaborative sort of user interface. So I collaborate with a lot of people, and we'll all just log in. We'll be looking at the same notebook, and somebody will update a paragraph, and we'll say, run it again, see what you get now. And it works out pretty well, actually. A lot of people like notebooks also because you can explain what you're doing. In the product, it comes with a lot of example notebooks. They're very simple because I actually kind of wrote a lot of these myself. Had some later on help improving them, but they're fairly simplistic. My first notebook, Anomaly Detection. If you open up these notebooks, you can use them as a template. So what I'm going to do here is go out of PowerPoint. I have this just in case it doesn't work. I'm going to go out of PowerPoint and show you the real demo here, if I have this thing working correctly, and here it is, and see if I can get this guy up at the whoops, not here. I'm not trying to do PowerPoint. I'm trying to do not this guy right here. Okay, so here is a notebook. So I did want to show you when you first come into Oracle Machine Learning, you have all these different notebooks, and what I showed you a minute ago were these examples, and I used one of these anomaly detection ones. But I'm going to go back over here to where I was in notebooks, fire up a notebook, sort these guys based on the most recent one I've done, and it's this insurance claims one. And I think I may have already put this out in the Analytics and Data Oracle User Community GitHub. If not, I will put that out there shortly. And if you want a copy of it and you don't find it out there, just send me an email. But we kind of explain what's going on with fraud. We can put a cute little picture in the upper right. We're sort of documenting for other people that might come in here and look at this, what's going on. And we have our nice little notebook. We first select star from claims. Now we could say add in there sample 10% or something if we wanted to. So we see our data, see all the data here. We come down here and start doing some very basic graphics, right? What day of the week do they have? Or the males and it looks like more percentage males maybe are having problems maybe on Wednesdays and Tuesdays. Fridays it looks like it's maybe the same ratio as Sunday. It's hard to tell, but usually when I do machine learning or when anyone does it, you want to kind of visualize the data. Most of the problems are happening in the urban area, not so many crashes or claims in the rural area. And we're looking at the day, what month is it happening? How many vehicles? One vehicle is the blue. 3 to 4 vehicles, so a few 3 to 4 vehicle accidents happen at certain times. This is what November, maybe the snow's just hitting. I can visualize the data in a few different ways here. As I go down, eventually I'm going to run this little begin. Remember what I showed you before? It's this, well, that's the drop the model. Here's where I'm going to build the model right here. So it's just like that other piece of code I showed you before. It's going to be a claims model. So if I want to use the GUI on premises, I can use the GUI. If I want to use the notebook, I can use the notebook. If I don't want to see this code, I can just say hide the editor, and I just run this thing. And then I'm going to display all the customers in probability of being anomalous. in descending order. So now I'm applying this to the data, and I get the probability of them being anomalous. I can then maybe start to come in here and visualize this data via the notebooks and see what's going on, but maybe show the top 5 where I rank them all and just say, show me the top 5 most suspicious ones. I've done all the math to figure people out. Here are the range of the probabilities. But the reason I'm showing you this is also because I'm starting to run out of the strengths of the notebooks for visualizing things. I may just want to sort of create a table called suspicious claims and push this, leave it right there in the database, and then come back and look at this using some other tool like, I'm going to get into here, Oracle Analytics, and see if this didn't time out on me or not, but I have Oracle Analytics, and there's a new feature where you can actually, from Oracle Analytics in 5.7, you can say, I would like to use the model that I just built using Oracle Machine Learning in the database, and I would like to register that model and apply it to new data and just score people from over here. So there's a new feature. I don't think I have a whole lot of time to show that, but notice how I can kind of look at some of the same data over here that includes these predictions. And I was just kind of, I'm a novice at this, okay? I'm learning it, but Oracle Analytics Cloud is so simple and easy to use. I can come over here and say, well, here are all the people that are likely to be anomalous. Were witnesses present, yes or no, and so on. So I want to kind of tease that as, taking this in the rest of the way for a total solution. So here was the notebook in case anything broke. Here's how I would do it if I use the drag and drop GUI. I'd use Oracle SQL Developers data miner extension, and I would do this anomaly detection that I just showed you before. Now, if I have a lot of examples, I might use the classification, okay, a different kind of thing. But I'm going to go into here and show you. I guess I'll just stick to the PowerPoints for a moment. This is the very simple one: claims, anomaly detection. So learn on normal data, build a model that shows me the factors of why it says it's anomalous, yes or no. It's not like, you're guilty. It's like, these are the factors that stand out. Could we talk about them? There were no witnesses. It's been more than 30 days. It was some external agent and so on. These are the factors. And so now I apply it to the same data, and I just rank and sort through these records and sort of triage them. And if I have enough examples of fraud, what would I do with those? I'd set them aside in a holdout pile, and if I got enough examples of them, I could take enough counter examples and go back and do a classification modeling approach, right? Because if you know what you're looking for, use a supervised learning technique is what the experts always say. So here I'm going to do some tax fraud. So I'm going to come in here and say, so we're a little bit different from the insurance claims. I'm going to take tax fraud. I'm going to view the data. There's the data. Was this compliant? Was this, like, let's say the government taxes? Who likes taxes? But we got to pay them. But are they compliant? Did you take out too many deductions? Did you get the right tax amount computed? Did you? I know some guys that were doing this. They had some very clever variables like was your IP address that you submitted your taxes from, was it unique to you, or were there 5,000 other tax submissions from that same IP address? So there are a lot of variables, not just the simple ones I have here, that you might want to use in your modeling exercise, and that's the beauty of allowing the data scientists to work collaboratively with the Oracle data professionals and do all the math inside the database. So now you might want to visualize the data, the adjusted tax income, and we're going to compute all the min, max, standard deviations. We're going to graph this using all the statistical functions that I talked about earlier in the database. If you are using R or Python, you can do the same commands, but it's going to push down to those SQL functions when you run it to compute it on all the data rather than just having to take and export a sample out to do the math. Here's where I'm going to do something called column filter. The column filter is going to say, show me the variables that have too many. It's sort of a data profiling kind of thing here. And what I'm doing in this supervised learning kind of approach is I'm saying, was it compliant, yes or no, and what were the variables, what were the key factors that determined if it was compliant or not? And there they are. Now I could just decide for modeling purpose to throw away the other variables or not, but sometimes your model accuracy improves, but it also tells you, does my model make sense? Am I on the right track? And then these are the variables that maybe I want to get more information in a more granular level on itemized deductions. So the number of late payments what was the population average? How many did they have? You might want to get a little bit more detail on some of these variables that are sort of rising to the surface. Now, once I've built a model, an anomaly detection model, it's what I showed before. Here are the factors that were most anomalous. I think we've switched back over here to the, what are we doing here? This is the tax. This is still the tax. So the adjusted tax income, the car ownership, that is it compliant? These are all different variables that sort of stand out. And now that I've applied the model to some new tax submissions, I can just run that and apply the results. And there they are, what I showed before with the predictions. And I can also do this over here with the reasons why. That's called prediction underscore details, and very powerful technique. So you may have a Gaussian or a very complex GLM model, and we would show you the reasons why. So now I'm going to switch over. Notice this was the unsupervised learning approach. Now I'm going to go down this little path over here to the supervised learning. So let's say I have labeled data. I have examples of what I'm calling compliant and examples that are not compliant. So here I can look at the nice decision tree and see the key factors. If, then I believe it's not fraudulent or compliant. It's not compliant, actually, in this case. 56% probability, and that represents actually less than 1%. So maybe it's something I'm interested in, maybe not. Maybe I want to take the probability of it being fraudulent times the dollar amount, right, and have an expected risk value here, expected exposure, and focus my energies on investigating those. I can also deploy this as a bunch of SQL code and just schedule it. But under the hood, when I do that, it's going to do what I showed you before, right? It's just going to be able to, that was the thing, build a model, schedule the model. I mean, build a model, score the model, show me the top results, and I can just schedule that to run on a daily, monthly, whatever basis. Now, when you go through the fraud, there are, I think, a lot of different ways you can solve fraud. And I don't pretend to be an expert in everything fraud. I think I know a little bit about some of the algorithms and a little bit about fraud, but there are plenty of people who know a lot about, their particular kind of fraud. Tax fraud is different from anti-money laundering fraud, which is different from medical fraud, and so on. So I don't want to try to portray that this is easy stuff. The people that do this are brilliant. They work very hard at it. But I do think that there are certain techniques and approaches that are able to be passed on to others, like, hey, did you try this? This is an interesting approach. And so I'm just going to identify some of the ones that I've seen or have been involved with. The first one is just the anomaly detection. I just want to apply a feedback loop to purify the input training data over time and improve model performance. So if I have a bunch of, let's say, insurance claims, or whatever, medical claims, whatever they are, purchase orders, and I want to say, well, show me the most unusual purchase orders or expense report items. Take whatever I have that I think are good, build the model, apply the model, take the ones that I think are possibly anomalous, remove them, go back, retrain the model, do the same thing, find the ones that stand out again. If they're normal, leave them in there. If they're assignable cause, kind of really, shouldn't be in there as normal, remove them, train the model again, and keep on iterating through that. As you have enough of these examples, like this guy over here and this guy over there, that you can say, well, I'm going to set aside those guys, and let's say we have a lot of examples. I say 25% or more. You could have 5%, 10%, or whatever. I use that as just sort of a rule of thumb, because ideally you'd like to have an equal number of counter examples to compare, to build a true classification model on. So that's another approach if you have the luxury, I guess I'd say it that way, of a lot of fraud. Clustering is one that's kind of interesting. This is what people have done, I think, in the early days of fraud, where they would say, well, I have all these records. I'm going to, in an unsupervised learning kind of way, try to put them in more homogeneous subpopulation piles. And then in those subpopulation piles, I want to kind of investigate them. And if you're not really fitting real well into this model or this subsegment, or you're not, the cluster distance from your height or weight or number of transactions doesn't really, it's in the cluster, but just barely, then that is reason for suspicion. Now, I think an even cooler thing, and that's something that's more easily done now that we've moved the algorithms to the database, why not just do step 3 and then step 1 to follow downstream, right? I can just do a script, build this model, and then apply it. And in fact, I think I have that over here in this. When I go back over to here, a little bit lower in the scripture, I have that right here. Do clustering, find out what clusters you're a member of, like this k-means clustering over here, and see, okay, here's all the different types of people that I have in my clusters, and there are people with this profile, and people with this profile, and this profile. I have all these different sort of profiles of people. Let me assign you to a cluster, and then for each cluster, run it through its own anomaly detection algorithm. So I'm doing my own sort of a model here, um, and it has its own variables that are for that particular cluster, and so on, and then take and apply that, and then apply it to your unknowns, and then each of these different guys here would give you your own list of the most suspicious records, but you fine-tuned it, right? You're saying for all the orthopedic surgeons, here's the high-end shoulder guys, here's the low-end shoulder guys, here's the whatever. You've identified 10, 20, 30 clusters here. I think that's a very clever and not so difficult way to implement things. Another way you can do it is a panel of experts. I can do many different models. 5 out of 7 models predict that you might be suspicious with a probability of such and such. Putting together assembling these analytical methodologies are a lot more easily done inside the database. And here's the example, I guess, of what I just showed before. Simple fraud detection model, just a one-class support vector machine. And here's the more sophisticated hybrid model. It's not so hard once you see how to do it. Now, you could do a notebook to do this. You could do it through Python. You could do it through the GUI. There's a lot of different ways to do it. The key thing is under the hood, it's running the same Oracle machine learning, algorithms that have been developed from the inside out of the database. So they're taking advantage of all the parallelism and scalability of the database as you do all this, as you're sifting through your haystacks of data. And it's much, much easier to just take and move this, fraud methodology to another platform and put it into production. Now, one of the cool things about this, I think, is the doing this all in the databases. I've mentioned this a few different times. It's creating these what we call engineered features. You might call it a derived variable, a computed field. In data science land, we call it sort of an engineered feature. And you may have things like lead lag functions that you're using to create rates of change over time for the usage. Ranking functions, rank their relative rank versus their peers in other records. So you're in the top of users of water, but the bottom users of heat. I don't know what, things that stand out. SQL windowing functions, the number of min, max, average amount of checks written over the past 6 months versus the last 24 hours, and maybe do the ratio between those. Use SQL patterns for the number of dropped calls or number of missed calls, or whatever you want. It's the keys to going in for the data scientist and the data professional together, data wrangler, data engineer, to derive all these cleverly derived variables that can then eventually be pushed into an algorithm. One of the coolest features I think for this is SQL patterns, and you'd have to go read the whole match recognize documentation to see the full detail and the full power of this. But it's pretty powerful, and you just would use this as yet another input variable into your methodology to set up some sort of a methodology and eventually see your results. So we're kind of coming towards the end here. Now I have my results. I have my reasons why I think something is unusual. So all of this is just running sort of inside the database. But wait, there's even more. And why not just use Oracle Application Express? And I have that sitting over here. I don't know if it's still going to work. It's probably going to time out on me. I have Oracle Application Express over here. Or it's going to give me headaches on my password or something like that. Yeah. Let me try this one more time. I hope that's the right password. If not, I might just punt. Oh, it is the right password. Good. And so now I'm doing this. I've switched gears because I don't have a fraud one per se. But imagine now I have all my results, and I have, okay, here are the most suspicious ones, and I just want to look in, say, the research and development department over here. And I want to say the ones that, yes, they are not attrition, but yes, maybe they are fraudulent, or those guys. And I want to say that, where they travel rarely or whatever, or just the guys that are the really likely to be fraudulent ones. And I've sort of sifted through this all very straightforwardly. I might want to need to communicate some of these insights, the reasons for things, to others in my department. I might want to do this as a mobile app. So as I'm walking around going door to door looking for fraud, I have a mobile app. And if I want to do some sort of interactive thing here, well, Oracle Application Express, I could put maps up here. I could drill through for the guys, in this case, the most years at the company with the highest probability of it says attrition, but this could be fraud. And I could drill through and see the reasons why. So there's a lot of cool things, I could do there. So I wanted to point that out. That's in case the demo didn't work. And also, one of the latest, coolest things that I really want to stress is Oracle Analytics Cloud is a wonderful product. It's gotten so easy to use over the years. And what goes better together than machine learning and Oracle Analytics Cloud. So now I have, some sort of notebook on the left, some sort of results, and this is what I'm doing. I'm registering a model. So I'm coming up here and, well, actually I've registered the model first. This is the data flow. I've registered a model here, and I can show this live, but I'm going to do this. I set up a workflow. So there's my data. There's my apply the model. I point at the model that I just built, the anomaly detection model, and I score it. And there are my predictions. I can do interactive filters, and see if I can show that live real quickly here. Is that it? It's over here. So here's my claims fraud. Here's something else where I have to say the marital status. Here's the month of the vehicle claim, and maybe I just want to say something like, well, I just want to look at all of the sport utilities. Well, now everything all updates just on the sports utilities. I can deselect that all. I can do the vehicle price, and so those guys, and I can have the probabilities of something being suspicious in here. But very nice ways for me to. I think did I put in fraud here? Just the guys that are yes, they're suspicious of being fraudulent. Updates the whole table. So once I have my predictions, I can do that. I can also go over here. I guess I have to go to the main page. I'm not going to be able to do this justice, but save changes. Sure, save those changes. And skip that. So one of the new features over here is if I have the right spot, I can also now register an OML model. So if I go into here to my Oracle thing, I have my insurance. There's a different kind of insurance there. Here's my insurance 98 Bayes, my insurance random forest model with the inputs, the outputs, and so on. And I can just register that and then come back here and set up a data flow as I showed you before. So pretty exciting times from Oracle to be able to do these kind of things. I think we're running out of time, but I wanted to say that imagine now you start, taking all your applications, Fusion Analytic workspaces and warehouses and other kind of applications that we at Oracle have been doing this, and you start to embed pre-built machine learning methodologies in here. Deloitte does this with their Deloitte Analytic Objects. They've done a lot of work in this space, and I encourage you to check those out as well. But the database has become a very fertile platform for not only managing security and scaling, all of your data, but also analyzing it using these embedded free machine learning algorithms. So I really think that's a really huge differentiator for you if you're a partner or a customer, just how much value add you can do from Oracle these days. If you do want to follow up and do anything more with this, there's a bunch of links that are here for hands-on labs, workshops, tutorials. There's this changing role from Oracle Data Professional to Oracle Data Scientist in 6 weeks. There's just countless different things. If you just Google Oracle Machine Learning or go to oracle.com/machine learning, you get to many of the pages and links. You can always send me something at charlie.berger@oracle.com and we'll get you going with something. And with that, I'll see if there's any questions, but thank you very much for your time and attention today. See if there's any questions here we can figure out. Where are the questions?
I can read them off to you while you search, Charlie.
Here we go. I got it.
Oh, there you go.
I got it.
Okay.
Can you give another example of supervised versus unsupervised learning? Because there's work on it. Yeah. Another example. I mean, the one I'm using right now is, are you going to buy a Tesla or not? Are you going to default on a loan now? I know some guys that are doing like invoice kind of fraud prediction. So you really want to know which invoices, it may not be fraud, but which invoices and which customers and which transactions are likely to take longer than the 30 days. So you really want to kind of take some distribution, and that's where if you read the blog, you want to spend a lot of time really thinking about what's your definition of anomalous, or do you not have a definition at all, so you completely go to the unsupervised. But Oracle Analytics Cloud also has their own machine learning. They use Python historically to do that. They just kind of wrap it and you move the data over to Python, it does its thing. But the better way of doing that nowadays is that you can also just call up a model that was done in the database. And if you use Oracle, the machine learning is free. You might as well just use that. That's what we really spend a lot of time focusing on developing solid enterprise-wide stuff. Is Oracle Machine Learning and Analytics a cost option? No, it's included. I said that a few different times for the anonymous attendee. It's included in all the Enterprise Edition, SE2 Edition, all the autonomous databases. So it's, again, I feel like Santa Claus. It's free. It's free beer. Everyone can use this stuff. Next one from Santosh. Hey, Charlie, we use ADW and we are not enabled on data miner capabilities since it requires system grants to enable. Is there any other way? No, you got to go down and talk to your SysDBA, or just stand up a whole other instance, or just go to the autonomous data warehouse. You could fire it up on the autonomous database free tier. If you just Google Oracle autonomous, Oracle machine learning getting started, I think is what you'll show you a little YouTube video. In about 3 minutes, you could set up your own free, like it's like Google Drive. You could use the autonomous database for free and use the notebooks up there. The drag and drop GUI that I'm showing does not work on the autonomous database. We have another user interface called AutoML that's coming up to do that. Next question from David. When will R and Python be available for OML? Well, R is available for OML, the whole product on premises. I think I showed that earlier. Python will be available in the autonomous version of the database in a short number of weeks. I know I've been saying that for a long number of months, but it really is this fall. And that will be on the autonomous, and then it'll take us a little bit of time to move that down to on-premises, and then we'll take the R and move that back up to autonomous. So R is available today, OML for R on-premise now. OML for Python will be available initially on autonomous this fall, and then they will both switch back and forth. Mauricio, hey, how you doing? Good to hear from you. Now he's got another question. Can it be combined with non-Oracle products? Sure. I don't know if there's a good reason for that, but I mean, if you wanted to take all your results and then come back and instead of using OAC, God forbid, and you want to use Tableau or Excel, sure, any SQL literate thing. Will the seminar have a certificate for participation? Not this particular one, but we are working on an Oracle machine learning curriculum that's coming out, and also a certification process. Is there a link to download the presentation? I think there will be. Can we get a copy? Yes. And if you don't get it, just send me a note. I can get it to you. You can also just Google Oracle machine learning. You'll see a lot of stuff. If we have a model that's created on-prem in SQL Developer Data Miner, how can you import it and add it to Oracle Analytics Cloud as one is on-prem and the other is OCI? Well, the model itself is just a model object, right? So that when I showed that little begin DBMS data mining create model, so if you go to the documentation, Oracle Machine Learning, and just Google that, Oracle Machine Learning 18C, 19C, or whatever, and then Google in the documentation model import or model export, you'll see how we do it. It's a model object, so it's just like exporting a table or a view. How easy is it to install Oracle Machine Learning? Well, if you use the autonomous database, there's no installation at all, right? Your DBAs are a little reluctant. Well, it comes enabled now in everything from what 19 or 20C, 19C forward. I think it's already enabled, but it's free. So just go to the documentation. Send me a note if you have any kind of questions on that. But the Oracle Data Miner is a little bit harder because you have to use SQL Developer and you run a little config. You just launch a little wizard. That's a little bit more involved, and it will ask for SysDBA. But the easiest thing to do, if you don't have a problem using the notebooks and the cloud, is just go straight to the cloud. In literally about 3 minutes, you could be up and running. And that's it for questions. Send me a note if you have any more. Thank you for all of your time today, everyone. I wish you the best of luck. I think you can have a lot of fun. Hopefully, if you do combat fraud and you have any kind of success stories like what the UK NHS has done and some of the other different guys that have shown, I'd love to hear about it. I'd love to promote or highlight what you're doing because who wants fraud? It costs us all money, and we can. There's now a tool that every Oracle data professional can now use. So give it a go, have fun with it, and thank you for your time.
Awesome. Thank you, Charlie. Thanks everyone for joining today. Bye now.
Bye, guys.